Okay, so what we're going to talk about today is conservation of momentum and collisions and things like that. So we're going to talk about the things that happen when two objects that both can move interact. Sometimes we don't have that situation, or one doesn't move very much and so we can ignore the movement. But a lot of times we care about when two things hit each other, two things collide. And in those cases we need to worry about how the interaction reacts between two things. The basis of all this is the law of reaction, and the law of reaction says that when two objects interact, the second object exerts just as much force as the first one on each other. So we'll call that 2 and we'll call that 1, so that the force on the first object from the second object is equal to, in magnitude, it has the same size as, the same strength as the force going the other direction, or from the other object on it, only with a minus sign, right? So if you're pushing on something, then it's going to push back equally. The minus sign means that whichever way you push, right, if you push a refrigerator, for example, you're pushing it forward, although it's not moving, and you're also pushing yourself back at the same time, or it's pushing you back at the same time. Your push on the refrigerator is causing the refrigerator to push back at you in the opposite direction. So that's Newton's third law. Okay, and this just says how two things interact with each other. And one important application of that, one thing you should realize is if you're walking, right? So let's pretend that's some pants. That's a shoe. Give it some shoelaces. And you're walking. You are pushing on the ground backwards, right? You are pushing backwards this way. That's what your leg is doing, right? You're trying to push backwards on the ground. And then the ground is going to push back on you going forwards. So you feel your leg going backwards. Feel your leg pushing backwards, but you go forwards. So that's basically what Newton's third law is saying. And the trick here is that these two numbers, these two magnitudes are equal. And that doesn't make a lot of sense sometimes, because we think a lot of two objects, one is really heavy, one is really light, and then they're going to accelerate at different rates. But remember, the acceleration is the force over the mass, so something that's heavier will accelerate less. Okay, next time I'll do an example. Bye now.